I think we can't really, I'll be honest, I was already thinking we were going to call it, but
No.
I think the wiser thing is we need to just keep going. Okay.
I think it's better to do it, yeah.
Yeah, so we're gonna do it. So everybody got chapter 10, right? I gave you one right now? Okay, so we're gonna move on to it. I'm gonna jump into it, which has to do with scatter plots and correlation. So meaning, I think I talked about it before briefly, in that you could have two variables, and one of them, right, which is fitting today, and this is just because this is a good example, but attendance and grades. Okay, so I shared this with you early on in the class, and so I've actually done this where I've mapped out like every student is a dot, and you end up with something like this, and then rarely you'll get somebody that shows up a lot, and then they don't do too hot.
There I am, right there. Seriously.
Okay. And then sometimes you get somebody that doesn't show up a lot, and so those we call outliers, right? They do well anyways, right? Because they maybe took the class before, or they just said right. They can read on their own. They figure it out, and they're disciplined about it somehow. But the general trend is, if you're present, what happens to your grade? As attendance goes up, your grade goes up. Okay, in math, to me, it makes perfect sense, because in math, it's sequential. You miss a day, it's going to be hard to kind of come back from that. Especially in this class, especially like on a Tuesday, Thursday class, you miss a day, you miss an hour and 15 minutes worth of material. So the point is, there's this thing we call correlation. Now, we want to be careful to say attendance causes us to have good grades, because that's not necessarily true. Okay, we only want to say that maybe we suspect there's a correlation. There's a correlation between attendance and grades. There's a correlation between the two grades. In other words, as attendance goes up, grades tend to go up. Okay, that's what I want to say. So you remember, I'm always tell you, I'm careful with words. Okay, you got to be careful with words. We don't want to say something for certain. I can suspect that attendance causes good attendance causes grades to go up. I can suspect that, but I don't want to state that. So we're not talking about cause here. Okay, we're talking about correlation in this chapter. Okay, so in the previous chapter we talked about hypothesis tests and confidence intervals involving two or more numerical and quantitative variables. But this is what we're going to do in this case. But we're going to test correlation. We're going to test correlation. We're going to test if two variables are truly statistically correlated, okay, or statistically correlated. So what is correlation? This is the method, and in short, what correlation is that, and in particular, what we're going to work with is linear correlation, because supposedly there's this line of best fit that I'll show you how to get on the calculator, and then also by hand too, but this line of best fit, what's correlation? Correlation is how far do each of these points deviate from my line of best fit. That's correlation. So something that looks, and maybe I might save it because I have a slide here. I believe I have a slide. Oh, maybe not. That's my other PowerPoints. Okay, so I'll draw it. So something that looks, like this, we call perfect correlation. And correlation is denoted by the symbol R. And perfect correlation would be R equals 1. Okay? Something maybe a little more scattered, but still has kind of that shape of a line. I might say this is about R equals 0.9 or 0.8. Okay? Because it still has kind of that shape. And then something more loosely correlated might have an R equal to 0.6, and then something, does that have any correlation, you think?
No.
No correlation. So this is r equals 0. R equals 0. So, and just like there are positive values, you could have negative values. Okay, if the slope is negative. Okay, so you could have negative values. Yeah, like here, just one example. Perfect negative correlation would be like that. That's r equals -1. Okay, so the r's range from -1 to 1. R's range from -1 to 1. And they tell you how closely they're correlated to the line of best fit. That's what correlation is doing. So that's what we're trying to do here. Can we say that there's any correlation between the x variable and the y variable? Okay, linear correlation. So the intro, are 2 or more variables related in this way? If so, what is the strength? Okay, so let's talk about the strength of the correlation. So this would be a strong correlation, right? And actually both of these would be a strong correlation. And then down here, we might say this is a weak correlation. Okay? And then down in the slides, I'll define it even more. And then what type of relationship exists? Is it a positive correlation or is it a negative correlation? As one variable increases, does the other increase? Let me just ask you on my attendance one. Is this a positive or a negative correlation?
Positive.
Yeah, because as attendance increases, grades increase. So that's a positive correlation. What kind of predictions can be made from this relationship? So, and I got pretty good at predicting student grades based off of attendance with an equation. It's not about being good at it, just using the equation, right? So I could see, well, and I can change this too. If I said this the way I posed it was number of present. That's how it appears, number of present days. But if I pose it the other way, it doesn't matter. But I can input the number of days present, and I can fairly accurately guess a student's grade based off of that. And that's not me messing with the student's grade. Don't get me wrong. Okay, it's me just getting everybody's, grading them regularly. I'm not trying to do anything extra. I grade the test fairly and whatnot, and they get put into the scale, and that's what happens. You can fairly accurately predict something that you think is seemingly random, right? Which is because this is not the only factor, right? And we can talk about that a little bit later, but there's multiple factors, right? Because your study time could have to do with it. The number of other classes you have could have something to do with it, right? Maybe outside external influences, the number of hours you work could have something to do with it. So there's all these factors, but it turns out attendance is seemingly, right? I don't want to say for sure, because remember what I said, it's not causation, it's correlation. But seemingly, attendance is pretty important to it. Okay, so R helps us determine how important. And then what kind of relationship, what kind of prediction. So in this case, I can predict students' grade based off their attendance fairly accurately. Are the two variables related? That's the big question. What's the strength? Okay, that's the other big question. So R, you might want to maybe put right here, is called the correlation coefficient. So that's just vocabulary. Okay, so R is the correlation coefficient. That's the number, and it could be from -1 to 1, -1 to 1. So that's what we call the correlation coefficient. The other thing on what type of relationship exists on the next slide here is, in a simple relationship, there are two variables, an independent, okay? And maybe on that, you could put a little note here. Do y'all know which one's the independent, the x or the y? In algebra?
The x.
Yeah. And then the y is the one that depends on the x, right? The dependent is the one that depends on the x variable, also known as the predictor variable. So in this case, on my example, what's the predictor variable? Attendance, right? So we use the attendance to predict
the grade.
The grade. Okay, we use the attendance to predict the grade. The grade is the dependent. So depending on the attendance, we can predict the grade. Okay, so then what kind of predictions can be made? well, basically whatever you're talking about. But here are some examples. You can forecast weather, stock market, sales predictions, crop predictions, gasoline price predictions, sports predictions. Some predictions are more accurate than others due to the strength of the relationship. That is stronger. The stronger the relationship is between variables, the more accurate the prediction is. So, like you can use this information to try and predict other things. And then there's actually ways you can use multiple independent variables to make your prediction even stronger. Okay, to get a stronger prediction. So that's why these things can be useful. All right, because you can, and really people that can predict and project and forecast are valued highly in companies, because if they predict accurately, you know, like for instance, can you predict the price that you should mark your item? I don't know, maybe you're selling, somebody in the Apple company has to decide what price they're going to put the Apple phones, right? Which is a real like fine line. So they mark them. I don't know, what do they cost now? $1,900 to buy an Apple phone. Yeah. So somebody has to pick that price, and it has to be a price where they want to try and maximize their profit, right? So if they're off by, you know, maybe they go over 100. And not as many people buy their phones now, because they said, okay, you went overboard. That's 1,100. I'll pay 1,000. I'm not gonna pay 1,100. And a lot of people end up saying that. Well, Apple loses out on a lot of money. So you have to have somebody, or they have to have things in place where they can predict what price these things should be. Okay, so prediction is a big deal. Okay, prediction is a big deal, because potentially for the company, that's millions of dollars. Right, millions of dollars for a big company like Apple. Okay, but even smaller companies, prediction is valuable, right? Like I always use the Bill Miller's example. If they use what are they have to buy brisket, right? So you have to be able to predict how much brisket, because you buy too much, what happens?
It goes bad.
It goes bad, right? You buy too little,
You don't sell enough.
You don't
sell out.
Yeah, so there's like a margin of error, right? That you'd have to buy. So prediction is important. This is just one of the tools to help predict, which has to do with scatter plots, which I already showed up here. Okay, so now getting into some problems. So one of the things I'll ask you to do.
God, we're going to have to draw graphs on the homework, aren't we?
No.
I don't think so, but even if you did, I think the scatter plots aren't as hard as some of the bar charts that you've had before. But more importantly than graphing on the homework is graphing on paper, okay? Because that's how you're going to be tested. So today we'll give you that chance to do that. So let's just start there. Here, you already have the labels made for you, okay? And even a step ahead of this, okay, just to get you to think, I think I'll give you labels. I'll give you labels, okay, just because of the time of the test. But if I didn't give you labels, you'd have to think, what's the lowest, what's the highest? 8.5, I'd probably start at 0, and then I'd probably go by 10s to get to 63. All right, go by 10s. And then I'd say over here, what's the lowest, what's the highest? I'd probably start at 0 on the y-axis, and then I'd have to go by 1s to get to 7. Okay, so that's additional thinking that you don't have to do right now, because I gave you an axis, okay? But that's just something to keep in mind. Okay, so first things first, take about a minute, plot these points, the x and y coordinates there. Okay, plot these points. Okay, so I get this graph here, and again on the graph, it should look somewhat like mine. Don't be over meticulous as far as mine's a little off, because mine might be a little off, but you should be in a general vicinity, fairly close. You should be fairly close. Okay, but again, these are sketches, so I'll treat them as such when I look at them. Okay, but what would you say? Is this linear or non-linear?
Linear.
Yeah. So this appears to be a linear correlation. Yeah, what we call this a correlation. You think X and Y are correlated here? The cars, and then I didn't really. We just kind of jumped into it, but cars in 10,000s for car rental companies in the United States for a recent year.
Well, is that A an outlier? Because it's just so different.
Yeah,
it's
it's
still on
different,
the line.
but it
Yeah.
still follows that same trend. Yeah,
Yeah,
it still
okay.
follows that same trend. So outlier, I might say, is one that's off the line.
Okay.
Yeah. Okay. So yeah, I would say it still follows the trend. Yeah. So this is cars in 10,000s. That's the number in their fleet, right? The number in their fleet versus the revenue that they make. So what could be a general conclusion here?
If you have more cars, you make more money.
Mm-hmm.
Yeah, that's it right there, right? So as the cars in their fleet goes up, the revenue in their billions for car rental companies goes up. Makes sense to me. Okay, so as you get more cars to rent out. So there is linear correlation between actually let's put a qualifier. There appears to be linear correlation between number of cars, I should say, number of cars and revenue for car rental companies. Okay. Now let's take this a step further, and I'm going to just show you how to get these equations. I'm going to kind of do it backwards this time. I'm going to show you on the calculator, and then I'll show you the calculations. Okay. So here's how you do it with your calculator. So if you want to take your calculator out, it'd be good practice for you. Okay. So, and I'm also going to write the steps for you. So you might want to have that down somewhere. So this is linear correlation. Okay, so first, stat, edit, and then enter data. I should say the word, enter data into L1 and L2. Okay, that's the first step. So I'm gonna stop. I'm gonna start doing that. So all your X variables, stat edit. I'll clear out what I have here, and I'm gonna put all the cars, right? So there's. Okay, so the next part, after I have this, I'm going to go back to, or I'm just going to put stat, push stat, calc, and then scroll down to linear regression. Okay, linear regression. Okay, so stat, calc, linear regression.
Which one, the AX plus B or the A plus BX? Or there's just a linear regression.
Yeah, it's you can just pick the first one. It really doesn't matter. But the first, I just picked the first one. So the only difference that really is that they put the slope over here,
Okay.
or the x on this side, or is the x over here. So that's all it is. Okay, but I just picked the first one. So now it'll say list 1, list 2. That's where our data's in, so we don't have to change that. And there is this thing that says store regression equation. Now, and a little bit for you ones that have the 83, it'll show that. But let me just go here. So once you get here, I'm gonna say on store regression equation, I would push alpha y equals alpha. I gotta push the buttons on this one. So alpha trace y1. Okay. Now some of y'all have that. Others may not. So then the other way to get y1. So alpha trace y1. I'll put that. I'm just gonna write that for those of you that do. If you don't, you have to follow this other. You can go and do it through vars. Let me clear this out. Vars, y vars function y1. So I'll write that too. Vars or vars y vars function y1. Okay, so that should cover everybody. Okay, that should cover everybody. Okay, so that's how you get y1. Now, for those of you that have the TI-83, well, I went too fast, but let's see if I can push enter. There it is. That's how you have to put it into your TI-83. However, you actually don't even have to put the L1, L2, because it defaults to L1, L2. So you should be fine just doing this paste. So what does the Y1 do, the store regression Y1? Okay. So we're supposed to be coming up with an equation and of line of best fit of this scatter plot. Okay, so once I push enter, it should give it to me. Okay, so this is the way for those that have TI-83, push enter. This is it. So at this point, what I want you to do is just copy all that. Okay, so copy all that. So we're gonna say y equals ax plus b, a equals to 0.1061. Did y'all get that?
I got that, but it didn't give me the R's.
Yeah, I just got the A and the B also.
So let's do, and really I should have said this first, because mine's set up and yours is not. Okay, so we're gonna go to, let me do it first and then I'll write it. So your R is not set up. So if you go to second catalog,
Where's catalog?
it's just 0, the number 0.
Oh, okay.
Yeah. So like second activates all the blue buttons and then catalog's right there.
Yeah, I just
So
never
then
used it before.
we're gonna go to just find the letter D, which is this button right here, and then we're gonna push that. That'll take us to the D's. Then I gotta scroll down to diagnostic on. Okay. So diagnostic on. Everybody found it?
Mm-hmm.
Okay, so the good thing about this is if you do it before the test, or before we have to, you don't have to do it. Okay, so this is just a one-time deal. Okay, so you turn it on, push enter. Once you push enter at diagnostic on, and you push it, it's done. Okay, now we repeat. But let me write that just in case y'all need it. Yeah. So again, what do? We did second, then the number 0 for catalog, and then just scroll down. Or what did I say? Pick X inverse for D, and then scroll down to diagnostic on. And then enter. I'll just push enter once. Enter. Okay. That's turning on R. Turn on R and R squared. Okay. All right, so now what did we do? We turned on R and R squared. So now I go back to my linear correlation steps. I already have the data in, so I'm not going to do the first line. I'm just going to do stat, calc, linear regression. Okay. Store the equation, alpha trace y1. Okay, or the other way I showed you. So now you should have R as well. Do y'all have R?
Mm-hmm.
Okay, who had trouble with it? Anybody have trouble with it? Okay. So now we write all that down. Okay, so we're gonna write all that down. Everybody's numbers agree with mine?
Mm-hmm.
Okay, so that means we typed it in the same. So then let's go to 4. We can go to 4. 0.1061 B 0.3963 R squared is 0.9643. 643 R is the square root of that 0.98198. Actually, I'd have to round that up, so that would go 20. Okay, 0.9820. So this is it. So what does that make the equation? Who knows? Y equals,
Is it the 9820?
well, it's in this format.
Yeah. Y equals 0.1061 times X
Oh, okay.
Times X
plus
plus
0.3963.
That's it. That's it.
Oh.
Okay, but I've always had students write all this because it's just helpful for you to have all this, but then it's easy to write the equation. Does everybody understand where the equation comes from? So right now, I mean, we just started, so you may not remember the process, but I think as you go along, it's not that bad. Stat, calc, linear regression. Stat, calc, linear regression. Alpha trace, store it. Okay, but let's talk about the store real quick. Where do we store it? We store it right here. Okay, so where we said store regression equation, we store it right here in y equals. So if I push y equals, it automatically pasted it.
Cool.
It automatically pasted it, but it used more decimals for us, which is better. On paper, I just wrote like 4, up to 4. Okay, so it stored it for us. So which leads me to my next point. But I mean, we're pretty much done. Okay, this is the other stuff. I mean, good stuff that is helpful. But okay, so now that we got a linear correlation equation, let's talk about a scatter plot. Okay, so scatter plot. First, you would go to second y equals. Second y equals, and default is that it would be off. Okay, default is this, that it's off. Okay, so that's default. So then second y equals, push enter here, turn the plot on, so I push enter on, and then I'm going to use the first type, scatter plot. And then it defaults to list 1, list 2, that's where we have our data. Now, if I push graph, oh, that was nice. Normally it's not that nice. Okay, my window happened to be there, right? Was y'all's that nice? No, right?
Where's the graph? Oh, I see it now.
Yeah, normally if you do a standard window, like 6, this is you probably see something like this. Most of y'all probably saw something like this.
Yep.
Right, depending on what where your windows were at. But standard window is -10 to the left, +10 to the right, -10 on the bottom for y minimum, and then +10 for the y maximum. That's the default window. So it's not a very good visual. Okay, so after we do the second y equals, turn plot on. Plot 1 on, okay, and then you do the scatter plot, right, down that button. Then what you should do is zoom, okay, and zoom 9, that's a special zoom. We call zoom stat. So for whatever stats we have,
Sweet.
it'll automatically fit the window for you. It'll automatically fit the window for you. So you see, this is the problem, right? Because default, we don't see anything. Okay, but now if I push zoom stat, which is number 9, you can either push 9 or scroll down. Okay. It'll zoom it in there, and then you'll be able to see the linear equation that goes through that. Okay. So that is what we call the prediction line. Which here, I want you to make this note. Normally we don't write y. For the prediction line, we put y hat, indicating that that's a prediction line of the variable x and y. Okay, and that's how you generate the graph. Now, but even further, this is somewhat helpful, but it might be more helpful to be able to see numbers on here. The other way I can see numbers, or one way I can see numbers, is pushing trace. Okay, so trace. Notice on top. I'm on the scatter plot, so if I move left to right, or actually up and down, no, left to right. Yeah, if I move left to right, I go between the points on the scatter plot. Okay, but really I don't want to be on the scatter plot, I want to be in the prediction line. So how do I get the prediction line? Just push up, and then you'll notice on the top, now I'm on the y equals the prediction line. Okay, so now I'm on the prediction line. There. So I could also type, right? So what is this problem talking about? It's talking about cars and thousands of dollars in revenue. Okay, so maybe I'm the executive at 63, or maybe I'm the executive here at 29,000 cars, or that's 290,000 cars. It's in 10,000. So let's say I'm that executive, and I want to say, okay, well, what if we increase our fleet to 50,000 cars? 50,000 cars. Where's my revenue? My revenue is going to be at $5.7 billion. Right? Predicted. Right? Because these are predictions. You know, sometimes in real life it doesn't happen that way.
How did you put that X in?
So again, trace. Just make sure you're not on the plot. You gotta push up to get to the equation, and then you just start typing from there. So just type. I'm just gonna type 50, enter, and then I keep typing other things too. I can type 60, enter, and then I have a prediction for 60,000 cars. I'll make $6.76 billion. Okay, and even you can go as far as. Here's the thing though, okay, just a side topic. This is the highest value that we have in this data set, right? So within this data set, you have like a domain. It's kind of dangerous to extrapolate, we call it, outside, or in other words, make predictions outside this X.
I did, and it gave me an error.
Oh, you did? The error might be, it's not that you can't do it. If you do like 100.
Yeah, I did 99.
Yeah, the only reason it gave you an error, not because it's invalid, like it says, it's invalid because it's out of the window. Okay, it's invalid because it's out of the window. But
what do you do that?
What's that?
What do you do less than the value?
Same, like if you did -10. Well, -10 in this problem wouldn't make sense, although you could do it mathematically, but the trace will tell you invalid too. And again, the reason it's telling you it's invalid because it's outside the window. Okay.
Outside the zoom window,
Yeah,
or outside the window of the values?
Outside the zoom window.
So if we zoomed out, it would let us find those lines?
Let's see. We'll zoom out. Okay.
No.
There it is. So I just zoomed out, and then I'm going to do trace again, and now I'll try 100 again. Trace. Oh, I gotta make sure I'm on the y equals. So push up. Now 100. Enter. Yeah.
Okay.
And why? Because what does it mean that you're putting 100 right here? It means that you're plugging in 100 into this equation. That's all it means. Okay. So that's the scatter plot. And then the final thing. Plugging in numbers or substituting. Okay, and basically it goes back to this. If you push alpha trace y1, and then you plug in whatever number you want on the home screen. On the home screen, you can kind of do the same thing as trace without all the problems with the zoom. Okay, so meaning if I go back to the home screen, if I push alpha trace y1, then I plug in 50, I get an answer. It does the same thing that trace was telling us. It's just basically all this does is plug in 50 into here. Okay, so a lot going on here. Hopefully you wrote some of this down because you'll probably have questions. What button do I push? Inevitably, I think you're gonna have those questions. Okay, so these are the buttons that you should push for those things. But then after a while, once you get used to it, it's not that bad. Okay, so that plugs it in. All right, but let's move on because we'll have some more to practice. Oh, actually, before we move on, one thing I'm going to ask you to do is to graph this linear equation right here. And the easiest way to graph it, not on the calculator but on paper, but the easiest way to graph it is to get 2 points. And just to model what I'd want is the way I'd want you to get those 2 points is the easiest way is to get a line.
Corner to corner.
Yeah. Plug in 2 points. 1 point that's kind of early on here, and another point kind of later on here. Convenient points, like what point would you pick around here?
1.5 and 8.5.
Well, X's.
Oh, 8.5.
8.5? Yeah, you could. I'd pick 10.
Okay.
Yeah, just because I like 10. Okay, so, but you could put whatever you want. It really doesn't matter. So I would pick y hat of 10. I had a 10, and then meaning I'm just going to plug in 10 into the equation. And then I'd have to pick a second point that I want to figure out. Maybe I should give myself some space here. A second point that I'd have to figure out. Yeah, well, so pick a point early on, then a point later on. What?
60.
60, okay, that's what I was thinking, 60. So 0.1061 times 60. And yes, I just showed you that your calculator would do this, but when it comes to the test, I would ask you to show, I want to know that you know what that means, which means just plugging in the number in there. That's what I want to know. This is how you're going to show me that you know that, okay? But yeah, your calculator can do it just like I showed you, but let's do it this way. 0.1061 times 10 plus 0.3963 plus 0.3963. Okay, that's the first one. 1.4573. 1.4573. Okay, and then the next one, if I plug in 60, I'm just going to edit, change the 10 to 60. And then I get 6.7623. 6.763. Okay, and what was the point of this? The point of this, I was trying to get 2 points. Point of this, I was trying to get points. Okay, so 10, what's the y coordinate? 1.45, right? And really, in reality, I don't need all that. I could probably round to the 10th because there's only so much precision here. So I just rounded. Y'all okay with that? You know what I mean? Yeah, so then over here, 60, 6.8. Okay, those are the 2 points I need to plot. Okay, now what I tell students, because there's two things up here. There's the scatter plot, and then there's a line of best fit. So the scatter plot I already put dots on. We're gonna change it up, not dots. Okay, we'll make, I like making X's. Okay, so for this, so I'm gonna go to 10, and then 1.5 is about here, make an X. And then I'm gonna go to 60, and 6.8, 60 is about here, 6.8 is about up here, and there's my X. And now to draw the line of best fit, I just connect the two. Okay, and usually on paper, I use a paper or something else, a straight edge. Then you make your, that's our line of best fit. That's our line of best fit, okay? Any question on that? Okay, so that's the entire process, right? But we have two more like that. All right, so we'll get some more practice in. Oh, here we go. This is what I was talking about. Okay, so except they did it the way I originally did it, which is number of absences. Okay, so first things first that I want you to do, go ahead and make the scatter plot, or graph the scatter plot on the next page. And if you're done with that, you can start typing it in. Okay, so your objective is put the data in, use the steps I've showed, get your A, B, R squared, R, and then your prediction equation, and then use your prediction equation, get 2 points, an early point and a later point, and then plot the x's. Plot the x's, okay? So, and basically everything we did on the previous one. If you have any questions, let me know. Were you able to get the R squared? Did you get it going?
I didn't get the
Oh, there it is.
scatter plot.
Oh, okay, this guy. So this guy. So you have it on. Okay, so if I grab, let's go to range error. So if I look at the windows, the reason it's giving you an error is because you're telling it that the lower is 10 and the higher is 10. Okay, so then if I change it to like the standard, you do
You
-10.
got a negative on the Y?
But you still run into a problem. Because,
check.
we're not going to see your data because the data's outside that window.
Just hit the Y
So
equal.
then there's an easy solution, which is the zoom ring.
Yeah.
Yeah,
So
okay.
try zoom.
Because it's a downward slope.
Ah, right there, buddy.
Yeah.
Okay, so it zooms around the data for you. Okay. And then you can see it. And then if you want to, you can trace it. And we're going to go on the scatter plots.
It's the slope and the offset, right?
Yeah.
We've been doing this a lot. We're talking about this shit in our machine learning class too. I wish I'd taken this one before I took that class.
No, then you'd have a concept.
Exactly.
Okay, so you have it done.
Together though has been awesome. I mean, could have been worse.
Oh, okay. Okay, so when you have it done? Yeah, write it down because if you do that, the editor will be done. let's try this out. So I went ahead and entered my data in. So now I'm gonna do the regression. So stat, right arrow to calculate, number 4, linear regression. And some of y'all might have skipped the store regression. I think it's good to put it in. Alpha y equals, oh, whoops. Gotta try again, stat, linear regression. Okay, so here we go. Alpha trace, actually, alpha trace. Y1, and then calculate. Okay, so then I got this. Did y'all get those numbers? Yep. Okay, so then I'm just gonna record real quick. 3.6219, B is 102.4925, R squared is 0.8915, and R is negative 0.94. Is that a 1, 2? Negative 0.9442. Y hat. What's Y hat? Or what do we do? What do we do? Put which one?
Plug in A and B.
Yeah, that's it. Okay.
Yeah.
That's all. As long as we know that, right? So you're just plugging in A and B. 0.6219x plus 102.4925. And just so you know, this is the, what do we call this in algebra?
The slope.
This is slope.
What do you
Okay.
call the other half?
Who remembers what this one's called? It's the y-intercept. Okay, so this is where the graph starts, and then this is the rate of change per, so really slope is the change of y over the change of x. And if you write it this way with no fraction, the change of x is 1. Okay, so for every 1 change of x, there's a decrease of negative 3.6219 of y. Okay, meaning what does that mean in this problem? In this problem, a change of x of 1 means that, 1 more absence. So this is a good thing to talk about. 1 more absence correlates to what?
3.6 points lost.
Yeah, 3.6 points or percentage points lost in their final grade, a student's final grade, according to this. Okay, so that's a good thing to know, the interpretation of what the slope means. It's a change of y over 1, a change of 1 in the x. Okay, in this case, 1 extra absence. Okay, so good. Did y'all pick points to plug in? So you should pick 2 points so we can graph this. Which points did y'all pick? Something early on, 2. Okay, now we plug in 2. Yeah, you don't have to think too hard about it. 3.6219, just pick 2 points. Try to keep them within the data set. And then the second point, you can give me a second point that you plug in. What's the second point? It's maybe some one towards the end. All right, I heard 14. Good, right? Good job, 14. So negative 3.6219, that's 14 plus 102.4925. Okay, so we see what's going on though, right? We're plugging in the 2 points. So if I do that, we'll just type it in, negative 3.6219 times 2 plus 102.4925. 4925. Okay, and then I'm gonna edit that, change it to plus. And again, did your points have to be these? No, it's not a must. Okay, you could have had the 2 different points and you'd be fine. All right, so then push enter. I get those 2 values. So 95.2, 95.2487. Okay, 51. Point. See, if only I would have known this in the beginning of the semester. Right, 2 absences, 95. 14 absences, 51. Okay. So then I gotta, those are the 2 points I'm graphing. Remember, these are coordinates. 95, 102. Try not to go into too much detail because I can only get so precise on the graph. Okay, and it's a sketch. Okay, so 295. Again, mark it with an X. I guess it should be scoot over a little bit. Mark with an X, and then 1451.8. 1451.8 would be about right here. Okay, and then I have my 2 points, and then once I get my 2 points, I can draw my line of best fit. Okay, which let me take the time to tell you that what we call this is LSRL, standing for least squares regression line, that we'll get into shortly, or maybe next time. Okay, but basically it's the line with the least distance to this set of points. That's what we found. The line of best fit is the line with the least vertical distance to these points. Okay,
And that's the line that the calculator already draws.
and that's the line the calculator gives us. Is this line? Right. And that's what. Yeah, that's the line that the calculator draws. Right. Which if I do the zoom stat, right, because it's already all in there because I stored it, so I should just be able to do zoom 9. Okay, and then I'll go straight to it. And that's, it pretty much matches what we have here fairly closely. So that's how I know I'm on the right track. Okay. All right, so good. That's a test question. Okay, that's basically a test question. I'll give you a scatter plot. I'm gonna ask you to find the LSRL. I'm gonna ask you to plot the scatter plot and then plot the line on that. Okay, that'll be pretty much a test question there. Okay, so we'll do one more. I think this one we'll just kind of do together because I think we've done it enough. You had a chance to do it already. Okay, so let's start again. It's a third example, but this time it's age and wealth. Right, so a researcher wishes to see if there's a relationship between the ages of the wealthiest people in the world and their net worth. The data shows a random sample of 10 persons selected from the Forbes list of 400 richest people for a recent year. Draw and label the x-axis. Again, it's kind of done for you. Well, okay, actually that's the one part I'll let you do. Go, do the scatter plot. We'll kind of do the rest together. Do the scatter plot. So take like a minute or two, draw the scatter plot, and then we'll just kind of do the rest. While you're doing that, I'll input. Yeah, okay, I'm gonna change my mind again, just keep going. I think it'll be good for you next. And you'll have it done.
Ugh.
Okay, so I'm gonna put it up for time here. So I already typed everything in. I'm just gonna push zoom 9. Okay, and then I'll see this kind of scatter plot. What do you think about this one?
Mm.
Messy? Yeah. So is it close to the line?
Some of them.
Some of them, it definitely has like a positive, but would you call this a strong or a weak correlation?
Weak.
Yeah, it's definitely a weak correlation. Now, if I go back to our linear regression, one thing that you might notice in some of the other ones that we had, the R here is 0.307, which is pretty close, which is closer to what, 0 or closer to 1?
0.
It's closer to 0. 0 indicating no relationship, no correlation. 1 indicating perfect correlation, like all the points are aligned. Okay, all the points are aligned. So that gives us evidence to show that there's not much relationship between these two variables. There's not much relationship between age and the wealth that leads to the top 400 richest people according to Forbes. Okay.
So what's the number cutoff for that? Like anything like above like a 0.8 or 9 is good or something like that?
Good question. So usually, I think different books say different things, but I would say probably about 0.8. 0.8.
Okay.
Yeah, so 0.8 would be strong positive correlation. After that, weak. Okay, after that would be weak. But you know, like I said, different books use different things, and then plus we'll also have. You know how we had like a critical value? There's going to be an R critical that I'll show you how to do, but I don't think I'll get to that today. No, I won't. Okay, so let's talk about some of the other ones, right? The R, and y'all have this. I erased it, so you're gonna have to help me out here for the final grades here. Can y'all tell me what was the R on that one? If you go back in your notes, y'all wrote it down. I erased it. What was R on this one? Point what? 9.4? Oh, okay, 0.994, which is pretty close to 1.
One.
Is that was that what it was? 0.99?
For the absences?
Yeah, 0.94.
0.9820.
Oh, that was R? Negative, right? Yeah, it should have been negative.
Oh,
Yeah,
I was-
because it's a negative correlation. So negative 0.98, which is pretty good, and you can tell the graph is fairly close to the line. Okay, what about for the very first one? What was the R here for car rental companies?
I think I wrote that one down.
Can you write it down?
Oh, did in the paper.
Yeah, I probably wrote it somewhere.
No, it's in the calendar.
Okay.
9820.
Oh, that one's 0.9820. Okay, so 0.9820, which is pretty close to 1. That means that that's pretty good linear correlation. So therefore, our model there is pretty good. Our model on the second one, or in other words, our equation is pretty good here. On our third one, would y'all say our model would be a good, our linear model here would be good?
No, not really.
Not as good. Not as good. So this is probably not a good prediction line. It's probably not a good prediction line. Okay, because it wouldn't accurately predict our values there. Okay, so just a few more things. Just like in anything else, right? So correlation is a statistic that we try to estimate true population correlation, the true relationship between two variables. Okay, we won't have it. We'll just have the estimate. The estimate is R. R is our estimate of what we call what's rho. So R estimates rho. This is sample correlation. Rho is population correlation. So we'll be dealing with R, and that'll estimate rho. And the linear correlation coefficient denoted by R is computed from the sample data, and the measures the strength and the direction, if it's positive or negative, of the linear relationship. So we've already talked about. So this tells us the strength is weak because it's pretty close to 0. Okay. If it's close to 1 or -1, then that would indicate strong. And then finally, we talked about this slide. Anything, and it doesn't say, but I'll just make a call here. And it'll change, okay, but in general, maybe around -0.8 and 0.8 after that. But again, we'll have like a critical value that we'll talk about next time that'll indicate whether something's strong or not strong. Oh, okay, and I did have this slide. So see, this kind of indicates a different, which one's perfect correlation?
Third one.
Yeah, the third one, that's perfect positive correlation. Which one's perfect negative correlation?
The sixth one.
Yeah, the sixth one here. Which one has the weakest correlation?
4.
Yeah, bottom left.
Yeah, bottom left. And then which one did you say is about 0.8? R equals to 0.8.
2.
This one. Okay, which one would you say is about R equals -0.7?
5.
Fifth one, good. What about R equals to 0.5?
1.
1.
The first one. Okay, good. Okay, so that's how that works. So you should kind of be able to put a number to it. This we won't have time for. We'll do that next time. But it looks big and scary, but you break it down. We'll break it down this way. Okay. Basically, you just do x times y. You do x squared, y squared, then you sum that, and plug these numbers in. You'll plug these numbers into that equation there, but we'll do that next time. Okay. All right. What I'll do is I'll probably post the homework, but I'm not going to make it due till the following Sunday. Okay. Your homework from this time was extended by request of your other class, so I extended it for y'all till tomorrow at 11:59. If you needed it, if you did it, then don't worry about it. Okay. Your review is available. Your online review. The biggest thing I would say, if you were to go through this, is look on your review. You have to know when to do what. Okay, and yeah, that's easier than it sounds, but basically, what I mean by that is on your formula chart, you should see the big thing is the test value on all these sections for hypothesis tests, because your test will be mainly chapter 7, 8, and 9, or 7, 8, 9, and 10. Okay, mainly, and you have to know which hypothesis test, meaning you have to know which test value to use.
Do we have another test before the final?
No, just the final. So next week we'll finish this off on Tuesday, and then on Thursday we'll review, and then probably actually start reviewing on Tuesday, hopefully. If not, on Thursday. Which is not an official class day, but I was telling Mike earlier that I would ask y'all next week whether y'all want to do a Thursday session, and most of my classes have already said yes. Okay, so because we're going to do final review. All right.
So you don't have any reading days planned, right?
Well, it's not required that you come on Thursday.
Oh,
Thursday's a reading day.
That's a
But-
reading day, so,
We're having finals review in here, if you wanna
yeah,
come.
but by mandate of the university, we cannot cover anything new. But we can hold sessions to review. So that's how I'll use it. Okay, and, again, nobody's required, but you're invited. And some other classes will be here. Okay, any other questions for me?
You have posted the